Well, this I can see is a numerical based question. It says the above lens is a convex lens, right? Of focal length 10 centimeter, the object of height 2 mm is placed at a distance of 5 centimeter from the pole. We have to find the height of the image. So let's begin with writing the information we have symbolically. First thing that I can see here, that we know here the focal length. And as you can see, it's a convex lens. And in case of convex lens, we take F as positive. So it's going to be positive 10 centimeter. The object height, right? Height of the object is denoted by h, and it is this time it is 2 centimeter, 2 millimeter. Well, you should know that there is no need to convert these into a single unit. Just that you have to remember that u, v, and f should be of same unit, and h and h dash should be of same unit. Now further it says that height of the object is 20 mm is placed at a distance of 5 centimeter from the pole. So the height of the object is 2 mm, and it is placed at a distance. So we have the object distance, that is u, which should be in centimeter, that is in centimeter. U is 5 centimeter. What we have to find the height of the image. Now we know that we have a relation for finding the height of the image, that is we know it should be h dash over h is equal to minus v by u. But then what we need to remember that in order to get h dash, we need h, we need u, we have, but we don't have v. And that's why we have to apply the lens formula. Well, it is a lens, so wait a second, h dash over h is equal to, it is v by u and not minus v by u, right? The correction is needed. So now first of all, I'll apply the lens formula, and that is 1 over v is equal to 1 over f is equal to 1 over v minus 1 over u. Now what I'm going to do is to replace the value of f, which is positive 10 over here, is equal to 1 over v, which is copied, and minus of, well, object is also kept in the, by convention, object must be kept on the left hand side of the uh, lens, and by convention, as you know, that u should be negative. So I should have taken this as negative. Anyways, correction done now is 1 over minus of minus, right? So that's why I placed a plus over here. Now check for the further working. I'm going to transpose this 1 over 5 to the left hand side. So it will come as minus 1 over 5 and is equal to 1 over v over here. Taking LCM, it's going to be 10. This is 1 times 2 times. So this is 1 over v. So it comes out to be minus 1 over 10 is equal to 1 over v. On transposing or by cross multiplication, we get v as what? It's minus 10 centimeter. Well, it should be correct as well. As you can see, image is formed on the left hand side of the lens. But then we have to find h dash, and we have already decided that h dash from here will come as what? H dash is over h, and what is h? H is 2 mm. So this is 2, and v is what? Minus 10 divided by u, and object distance is minus 5. So sorry, this is minus 5. So this minus get cancelled. This is by 2 times. We get h dash as positive 4 mm. So things you have to remember, yes, it should be positive because it's virtually rect and enlarged. So that's why it's bigger than the object. Height of the image is 4 mm, which is greater than 2 mm. So I can see that this should be the correct option. As I said, the unit of h and h dash should be same over here. And in terms of other, whatever the unit of f should be the unit of u, and that should be the unit of v. Many of you get confused that they should all be in the same unit. That's not true, because we are dealing with the ratio over here, and therefore we need to see that these two must be of same unit and these two must be of same unit. In this question, we are given the diagram, right, that shows the arrangement of cells inside the leaf of a green plant. And what we have to find, which cells normally contain chloroplast. And this is the reason I have taken this diagram from the textbook. As you can see, chloroplast is present over here, right? That is 2. And you can see this is the guard cell over here. That means the chloroplast should be present at 4, right? Over here, right? So 2 and 4, that is option C is correct. In this question, we are given a reaction over here, chemical equation is given for a reaction. This is what when iron reacts with water to produce steam and hydrogen gas is produced. Well, I think it's wrong. It's a steam here, right? So that's why it's a iron oxide and hydrogen is produced, and based on this, we have to write on which is the correct. So it says iron metal is getting oxidized. As you can see, iron is getting oxygen, right? So it is clearly getting oxidized. So first is correct over here. The second is says water is getting reduced. When I see water, it is H2O, it is losing oxygen. So loss of oxygen is reduction. So this is also correct. The third is water is acting as a reducing agent. So you should know that the substance oxidized, right, act as a reducing agent. So here I can see iron is getting oxidized, as I can clearly see that iron is getting oxidized. So it should act as a reducing agent, right? So this is incorrect. And water is acting as an oxidizing agent. Well, water is acting, as you can see that water is getting reduced, so definitely it is acting as an oxidizing agent. One more time, it is the water which is supplying oxygen to this. So water is an oxidizing agent, acting as an oxidizing agent. So it should be what? First, second, and fourth. Yes, B is the correct option in this case. In this question, we are given figure A, B, C, D, and in order respectively, and we have to find out which statement is correct over here. So what I can see from the first figure that here the image is formed before retina, right? So this is nearsightedness, or we say short-sightedness, right? Where a person can see nearby objects clearly but cannot see far off things. So this figure is for nearsightedness. So I can see that the A also says that short-sightedness. B also has the first part as short-sightedness, and I should discard these options. Now, when I see the B, B is what? Correction. As I can see, a concave mirror is used in case of a short-sightedness, what's also called myopia. So when I see the option, the second one, the correction of long-sightedness, clearly this is incorrect. A concave mirror is used for correction of nearsightedness, myopia. So I can see that here the correction of short-sightedness is given. Now that is the third diagram is what? This is a case when the image is formed behind the retina, also called, the defect is called hypermetropia, where a person can see far off things clearly and cannot see nearby objects clearly. So this is long-sightedness, that is hypermetropia. And that's correct. And the last one also, right? The option D, as you can see, we have dealt with the C part, but then is another statement, that is correction of long-sightedness. Yes, that's true. We should know that a convex mirror is used for the correction of that's long-sightedness. So we'll correct option will be option B in this case, right? Option B is correct. In this question for the diagram, like I can see we have a diagram over here as shown, and this is according to the new Cartesian sign convention. The magnification of the image formed will have the following specification. But before we read the option, let's understand this is a concave mirror where the object is placed between F and O. And what do we know? That when the object is at F and O, the image formed is virtual, erect, and enlarged. I can show you with the diagram. Say the ray parallel to the principal axis, after refraction, it will pass through the focus. But when this ray is produced backward, as I can see, if I produce it backward, this has to be represented by dotted line, something like this. And the other ray, let's say if I make it pass through the center of curvature, it goes undeviated, right? And let me show it properly as it goes like this, right? It goes undeviated. I mean, it will rebound back on the same path. That's what I mean to say. But when this ray is produced backward, they are going to meet, right? As of now, I don't have space, but then if it meets, not if it meets, it will meet, and the image formed will be what? Behind the mirror, and it's going to be virtual erect and enlarged. So for virtual erect, the sign is positive. So I can see these are positive values here. But then since it is enlarged, the magnification is going to be more than 1. So we can see that A is the correct answer in this case, matching both the condition. That is, one, it should be sign is positive, and then M has to be magnification, which is the ratio of size of image to the size of object. And when the size of the image is more than 1, we say it's magnification. When the size of the image is more than the size of the object, we say its magnification is greater than the magnification greater than 1. We are given a table over here, as you can see, and it says 4 student ABC, right, separately measured the pH values of each of the following samples. And the samples are what? Distilled water, oxalic acid, dilute hydrochloric acid, and a solution of sodium hydroxide using pH paper. And we have to find out which of the following. After reading the table, we'll have to find out the correct pH reading. So first is distilled water. As you know, pH of distilled water is 7, is a neutral. So all of them are 7. So this can be any of them. For oxalic acid, it is a mild acid, I mean organic, at the same time non-corrosive. So its pH should be around 3. So these are correct. Dilute hydrochloric acid is what is a strong acid and its pH is 1. So all of them are correct as of now. But when we look into sodium hydroxide, here these two are correct because sodium hydroxide is a strong base. Its pH is 13, right? Close to 14 only. So that's correct. Now we can see that the one which is correct for all of them has to be this one, right? So therefore, D is the correct answer in this case. In this assertion reasoning based question, it says assertion says change in color of copper from reddish brown to black is an example of reduction. Let's first understand the reaction. What we know that copper, when we burn copper, right? Copper which is reddish brown in color, if you burn in the presence of oxygen, it results to give you copper oxide. And the change in color is what you have to remember, that copper ordinarily is reddish brown in color. It changes to black over here. Although this is a reduction, but redox reaction, but over here copper is getting oxidized to become copper oxide. But then there is a reverse reaction also when it is heated in the presence of oxygen. What it results to give you, it gives you copper back. So what you can see that from here, the black color of the copper oxide, the black colored copper oxide on reduction, right? What you can first of all, let's deal with the color here. What you can see that we get back the reddish brown. Copper is ordinarily reddish brown. Now, when you read the question, it says that the color of the copper oxide, copper, from reddish brown to black is an example of reduction. Right, this is not reduction. As you can see that in this reaction from reddish brown to black is not a reduction, it's an oxidation as oxygen being added over here. And this is reduction. So we'll say that here assertion is wrong. And hydrogen is removed. Well, in case of this, the hydrogen is removed. In this MCQ, it says that in a double displacement reaction between aqueous potassium iodide and aqueous lead nitrate, a yellow precipitate of lead iodide is formed. That's very true. That's what is the reaction about. Now it says that while performing the activity, if lead nitrate is not available, which of the following can be used in the place? Well, let's understand why should we discard the first option over here. You know that it's a compound of lead, but it is insoluble. As you know that during the double displacement reaction, we use aqueous compound that is soluble in water, but it's insoluble. So this has to be discarded. And therefore, we'll be looking for the other compounds of lead. Well, these two also be discarded for the reason that they are not compounds of lead. So therefore, we are left with the correct option as the lead acetate ordinarily is used if what is not present, if lead nitrate is not present, then we use lead acetate. In this question, we are given a VI graph, and I can see that they're talking about two wires A and B, and their slope is given here. It says if we connect the both wires one by one to the same battery, which will produce more heat. Now look into this. If you look, this is a VI graph, and what you have to see here that the slope, right? The slope represent the resistance. What you can see that the slope of the wire A, right, or the conductor A is more than B. So they definitely the resistance of this wire is more. Now, ordinarily, what we know that higher the resistance, well, higher the resistance, high is the heat produced. So what we know that, like say for example, a wire which is producing more, which has more resistance for one or other reasons, maybe because of the resistivity or other factors, will produce more heat. So under this condition, right? Therefore, what we will say that more heat is produced in the wire A. So A is the correct answer in this case.